everyone. I'll try and keep my videos very short. Today's video is just introduction to structures. It's a very because if you cannot get the concept that we'll be discussing on this video, then we will have struggles at the later stage when you are analyzing the structure. For any structure, guys, you must always make sure that you apply the Newton's third law. For every action, there is an equal and opposite reaction. How do you achieve that? The equations are there. We are told there that you must always look at equilibrium of forces in the x direction. X is represented by is representing the horizontal forces, y representing vertical forces, and m is the then the next thing that is very important is that you all know, guys, that for every structure that we see around, obviously subjected to forces, and those forces will result to stresses developed in that structure. So our job as structural engineers, we must be able to resist those stresses. We must be able to resist the forces. How do we go about to resist the forces? There's external applied forces as loads that are applied to the structure. Those forces, first of all, they must go to the ground. They can't be just disappearing on the structure. They must go to the ground in the form of reactions. Stresses will be developed on the right hand side of the slide. I've mentioned which stresses we'll be dealing with what in this course, and then there will be shears depending whether you're analyzing a truss or a beam. Obviously, if you're analyzing a truss, and then you won't be looking at shears and moments. But if you're analyzing a beam, you will be looking at shears and moments. Mainly for trusses, we will be looking at stresses. Which stresses are we going to be looking for if we're dealing with trusses? Those are your tensile stresses and your compression stresses. So the first two stresses on the right hand side of the column are mainly for trusses, are mainly for frames, because some people they refer to trusses as frames. So the last two stresses that are listed there on the right hand side of the columns are for the beams. So again, I'm repeating, if you're analyzing a beam, you must be able to look at your loads, calculate the reactions, then you look at your bending stresses and your shear stresses. Whereas if you're looking at a truss, then you're looking at your loads again, you look at your reactions, and then you calculate your compression stresses and your tensile stresses. The loads that we're going to be dealing with, remember, guys, don't be confused now. What are these arrows? Why is the arrow going up and down? All the arrows that are what the arrows are doing, they're just showing that if it's a vertical load, it can go up or it can go down. If it's a horizontal load, like the second one, it can go left or go right. The third one, that's the most important thing. What about that one? Is it going up or down? Remember that load has got two components, the vertical component and the horizontal component. And then when we are dealing with the calculation, I'll be showing you how to work out the vertical and the horizontal component of the load if it's applied to the beam or to any structure at an angle. So I hope you are not confused about that. These are point loads and the units are in kilonewtons. Look at this uniformly distributed load. Look at the units for uniformly distributed loads. They are in kilonewtons per meter, meaning we need to do something here. Again, I'll address now how do you convert it into kilonewtons. And then the fourth one, which is a moment load, is in kilonewton meter. Please don't confuse the two, guys. The uniformly distributed load is in kilonewtons per meter. The moment load is kilonewton meter. Let's not confuse if you apply the Newton's third law, that every action there must be a reaction. So the reactions, which reactions are going to be dealing with here? Mainly three reactions that we're going to be dealing with is the pin support, which has two reactions. It can resist anything going in the horizontal direction, anything going in the vertical direction, regardless of how what is shown on your diagram, whether it's regardless. Let me just say regardless of how it's shown. Then you look at the roller support. The first one is the horizontal roller. The horizontal roller is got a reaction in the vertical direction only. The second one next to it is a vertical roller. The vertical roller is got a reaction in the horizontal direction. And then, last but not last, is a fixed support, which has three reactions: the vertical reaction, the horizontal reaction, and the reaction. Whenever we are analyzing a structure, we must make sure that the structure has got a minimum of three reactions. Remember, guys, you cannot have three roller support reactions. You must have three reactions. At least out of those three reactions, you must have one reaction in the horizontal direction and one reaction in the vertical direction, or maybe two in the vertical direction and one in the horizontal direction, or two in the horizontal direction and one in the vertical direction. So you must have at least three reactions. So if you can think about it now, going back to the previous slide, a fixed support has three reactions. That is more than enough in any structure. Think about the cantilever, we'll discuss that later on. It's got three reactions, which is the vertical, the horizontal, and the moment reaction. Whereas another combination that you can use, you can combine a pin support and the roller support together. It's going to give you three reactions. Two is going to be going in the X and Y, or Y and X, and the third one is going to go either in the X direction or in the Y direction. It is very, very important for the structure to be regarded as a stable structure. So please, that is very, very important, because the next slide is going to be, we will be calculating reactions. So if you are not familiar with this concept, then you won't know how many reaction in a pin support and how many reactions in a roller support and how many reactions in the fixed support, and then you will end up messing the reactions. I just hope that the video is good enough, at least to help you guys understand what you will be dealing with when it comes to structures. And then expect the next video in few days, which is going to be showing you guys how to calculate your reactions, how to deal with the laws that we've discussed earlier on here, in terms of converting them into whatever units that we want to convert them to. But remember, guys, units are very, very important. And remember, guys, always whenever you are solving a structure, you think about the equations, the three equations that I've mentioned earlier on. Always apply them. Thank you very much.